Hello everyone and welcome to Abaqus FEM. If you're a structural engineer, civil engineer, researcher, graduate student, or anyone interested in advanced finite element analysis, then today's training package has been designed specifically for you. I'm excited to introduce our new concrete and composite slab analysis in Abaqus package, one of the most comprehensive collections of slab modeling theories we've ever developed. This package contains 36 advanced hands-on workshops that guide you through the complete process of modeling, analyzing, and interpreting reinforced concrete and composite slab behavior using Abaqus. Unlike many training courses that focus only on one basic example, this package is built around real engineering problems inspired by published research papers. Every workshop demonstrates practical modeling techniques that you can apply directly to your own research project, engineering design, or industrial simulation. Throughout the course, you'll learn how to model conventional reinforced concrete slabs as well as advanced composite systems using modern construction materials. The workshops include simulations involving ultra-high performance concrete, ultra-high performance fiber reinforced concrete, normal concrete, high-strength concrete, a steel concrete composite system, hollow core slab, profile steel deck slab, timber concrete composite, aluminum concrete member, sandwich panel, and many other innovative structure configurations. One of the major strengths of this package is the wide variety of loading conditions that are covered. You learn how to simulate static loading, dynamic loading, three-point bending, four-point bending, low velocity impact, high velocity impact, rigid body impacts, punching shear behavior, fire exposure, blast loading, underground explosion, underwater explosion, and close range blast scenarios. These are the type of analyses that researchers and uh, consulting engineers increasingly encounter when designing resilient and high performance structures. The package also introduced a wide range of advanced Abaqus techniques that are essential for realistic nonlinear simulation. You'll learn how to use concrete damage plasticity, as well as various to material model, strain damage model, and define sophisticated contact interaction, create reinforcement using embedded region, implement cohesive interaction for bounded interface, simulate crack propagation, explosion phenomena using both CEL and SPH model, and blast loading also. In addition, the tutorial explain how to account for a strain rate effect, damage evolution, fraction behavior, and material non-linearity, helping you produce simulation that close match experiment observation. Each workshop has been prepared in a clear step-by-step manner. Instead of simple presenting the final model, we start from the beginning. You'll see how the geometry is created, how material properties are defined, coding for the material, how reinforcement is modeled, how interaction and boundary conditions are assigned, how meshes are generated, how analysis steps are configured, and finally, how to interpret a strain displacement damage, pattern, and failure mechanism. The this practical approach allows you to understand not only that what doing Abaqus, but also why each modeling decision is important. The package is organized into several major models. The first models focus on punching shear behavior and impact analysis. As you can see here, these are the example of the title here, 9 example. The second model covered the flexural behavior here. You can see it is about 10 example. Then the third is dedicated to fire engineering, 2 example. The fourth module introduce fracture mechanics, XFEM, and structural connection include 3 models. The fifth module focuses on the blast resistance concrete and composite structure here, about 6 or 7 models. And finally, the last 2 models here, see here, the SPH explosion. By the time you complete all these 36 workshops, you'll have developed practical experience with a wide range of nonlinear structure analysis that are rarely found together in a signal training package. If you're a master or PhD student, it can significantly accelerate your research by helping you build reliable finite element models. If you're a university researcher, you'll gain practical modeling techniques that can support journal publication and research projects. If you are a consulting or design engineer, you'll learn advanced simulation methods that can improve your engineering analysis and decision making. And if you're already familiar with Abaqus but want to move beyond basic tutorial, this package provides an excellent pathway toward advanced professional modeling. By the end of this training, you'll be able to confident to build high fidelity models of the reinforced concrete and composite slab, perform sophisticated nonlinear analysis, investigate structural damage, validated your numerical model against experiment data, and apply this skill to real engineering challenges. At the end, we have the payment section. Here, the price for this package, full package, is 154 euros. We accept PayPal, Visa, MasterCard, and cryptocurrencies for the payment. Before payment, contact us through this email to tell you more about the payment process, the content of the package, or anything that you need to know. For now, thank you for your attention.